Okay, so today we're going to do this question here. So basically, we'll read the question first. So the graphic shows an uplighter in the form of a hyperbolic paraboloid surface. The figure C2 shows the plan elevation and end view of a similar uplighter. An isometric view is also shown. So we have a 3D view here. The surface of the hyperbolic parabolaid is generated by translating a parabola ABC. It's generated by the following: in a horizontal position towards the parabola BD. B is the vertex of the parabola ABC and D is the vertex of BD as shown. So this is a particular important one in terms of just how it tells you to approach the question. So if you look at it here, which is unusual, it says draw the given plan as part A, then it says do the end view as part B, and then it says C, do the front view. So what that suggests here is that there may be some work here. Now there is a few different methods to do this. I covered this in the 2019 question. We're probably going to use the hyperbola method for this because it's the quickest method, but we look at the various sections of it first. So the first thing we need to note is that the scale is basically 1:2. So 160 will become 80, 180 will become 90, 300 will become 150, this becomes 30, 45, 45 and 30, and they're my various measurements that are broken down. So what we'll do first is we will start with our XY line and we'll leave space for elevation, even though that's not what it has asked us to do first. So I'll draw a ground line across the page and straighten that up like so. Okay, and what we'll do is I'm just going to leave a space for the elevation, even though for the minute I'm not going to use it. So we know that the width is 150 and we know that the height is 80 in the scale down size. Okay. Okay, so we have our bit there for our elevation. So what we'll do now is we'll leave a gap maybe of about, let's see, 15 maybe. And we'll start to draw out our plan view, or a rectangle at least for a plan view. Yeah, it says to draw the plan first. So we know that we come down 90. And we'll draw this across. And we have a few other measurements. But we'll just go with the center measurement for the minute. So half of 150 is 75. Here we go, bring this down. So there's my vertex. So what it said was B was the vertex of the parabola A, B, C. So this is going to be my point. So this is the point that my angled lines will hit. So this here is an even measurement and this here is an even measurement. So divide easily by 5. But just for the sake of showing that I can do the division line method, what I'm going to do is I'm going to draw out a random line here like so. I'm going to put 5 equal marks on it. So again, it's questionable whether this is necessary, but just to cover ourselves to show that we can do it in case it is required in the exam, what we'll do is we'll draw it in. So we'll join our last point to here. Okay. And we'll use our adjustable set square to draw parallel lines. Now you could also just use sliding set squares here, it depends what you have handy, but most of you should have an adjustable set square. So there's my 5 points. So what I'll do is I'll literally mark them across the other side because it's symmetrical, and we'll start to construct in the basic shape. So these here will go okay, so 75 then divided by 5 is 15. And these straight down. Now again, you could technically use a mirror method if you wanted to get the points on the other side. So Let's get you another parabola on this side. Most people will just redo the same method on the other side because it's as handy and as quick. So 15, 30, 45, 60. Okay, so so what we have then is we have this shape here, and we know that if we come in 45, which I have a mark for, so that's those pink lines, I have 2 points here. Right, so this is in 45, or 545 from center, and this. So basically I have some sort of a curve here. So what I can take now is, I know that this parabola here shape is exactly the same as this, albeit cut off. So what I'm going to do is I'm going to take my compass, and I'm just going to translate the parabola. Now I could translate it all, but technically I only need to translate the bit that I'm going to need to construct. So you take this distance here, and step it off, relatively quick to locate most of the other points. Okay, now what I might do is I might just very quickly show you how that would have continued on, just for the sake of saying. So technically that would have continued on like that, and would have been literally the exact same as this. But that's literally just to show you how it'll work on that. So that's not part of our plan or elevation. So what I'll do is I might get the typics on it. Well, actually, maybe I'll just mark the other side when I'm at it, just so that you can see how the translation method is working. Okay, so basically, if I did that, all I'm doing is basically moving that down the exact same distance as that, and you can see that shape there will be exactly the same as this. But again, that's just to prove a point. So what I'll do is I'll get my typic. So that's the plan view done, which is what they said for part A. So part A is complete. So that's perfect. So what I want to do then is, it says project the end view. So I'm going to take my 45-degree set square, and I'm going to project over my end view. Okay, so this up at 45, move this up at 45, and we need to bring across this line here as well. Okay, so by pure luck that landed on that exact point. It may or may not, maybe slightly above or below in your question. And I now have my box for my end view. So I have this point here now, which is D, and this point here, which is B. Okay, so what we need to do, basically, we know this is a parabola or a semi-parabola, so we need to make a box out of it first. The next thing we need to do is we need to split it into 5. So 80 is the height, so the first thing we'll do here is 80 divided by 5 is 16. So 16, 32, 48, 64, and there's my various points. And then this may be a random distance. So what I'm going to do is I'm going to use my divisional line method. So I'll draw a random line here, try to keep it low so that it stays in the projector. Mark 5 equal parts, 1, 2, 3, 4, 5. Just move that down a tiny bit. Join the last point back like so, and then again I'll use my adjustable set square. Okay, so I could use sliding set squares. This is probably the most accurate method, but both are perfectly acceptable. So I have 5 splits on each side, but this one here, I'm not 100% sure should it be here or here. What I need to do is I need to see, well, where is the vertex? So if we look at the question, it says D is the vertex. So this is this point here. So that means that if it's the vertex, it's the point that the sloped lines of all random slopes should be joining to. So I have this on the right side. So what I'll do basically is I'll join these sloped lines to here. And then the opposite points will either be horizontal, well, will be parallel to this line here. Okay, so in this case they're horizontal across. They're usually horizontal or vertical, but it would depend. The parabola may be or the rectangle for the parabola may be at an angle. So what I'll do now is I'll label them with numbers. Okay, so 1, 2, 3, 4, 1, 2, 3, 4. So where 1 and 1 cross gives me a point, 2 and 2, 3 and 3, 4 and 4. And we have our curve there. Now, it wouldn't be uncommon to have done that the wrong way around, and again, hopefully you'll cop it. But basically, D means it's turning point for the full parabola. It would be a shallow parabola that would come around like this. So what I'll do now is basically I'll heavy in my end view. Okay, so we have our end view. So now we've part B done. So what they ask now then, it says project the front elevation of the uplighter. So if we bring up these 2 points here, we have V1 and V2. And I'll just extend these lines up for a minute to make a rectangle out of it. And then we know a few different things. The first thing we know is basically this is going to create a hyperbola, because what it says is basically the translating a parabola in a horizontal position. So we know that this shape is going to be hyperbola. That's basically just a rule, and as we did in the previous 2019 video, we can prove that by doing the question and finding the points by doing 2 different ways. So the one thing we could do is we could take the widths here, put them on this. Sorry, taking the, well, I suppose their widths here, putting them on this and basically locating these points and then bringing them up and doing it that method. Or we have V1 and V2, so we could use the hyperbola method. Now in this case, this would be the easiest method. So this here is basically 80. So 80 divided by 5 is 16. So 16, 32, 48, and 64. Okay, and this here is a random distance. So we will, oh no, it's not, sorry, it's 30. So we'll just do 6. Okay, so if it was a random distance, I would have done division of lines, but I'm happy enough with it. So sorry, these marks here should actually be on the top. Okay, so again, the question sort of becomes then, which ones do these go to? Do they go to V1 or V2? If you join these to V2 and join these to V1, hopefully you'd see there that they won't meet. So these ones here must go to V1. And these ones here must go to V2. Okay, so to me, that's the quickest method to do on the question. It takes the least amount of time, less likely to get confused with, but it hinges on the understanding of a rule that basically this is going to give us a hyperbola. It doesn't tell us directly in the question that it will. So the alternative method is to take one of these widths and we just prove that. So we just take one at random just to prove it. But what I'll do, well, what I'll do for the main point is I'll mirror these across. So this point here and this point here to start with, we just mirror across. So again, you could do this exact same construction over this side, but it's probably as simple just to mirror these. So I'll just show the mirror method for the top 2 points, and then we just take a bottom point just to show an alternative method. Okay, so we'll put that back up there. Okay, so what we can do is take this distance here, mirror it across, and do the same here. So that's a perfectly acceptable method. Okay, now the alternative method, which is probably the least likely one that I would do because it's just a bit longer, but it is important to know for this question, is to use the height and width method. So what we could do basically is take a width here. Okay, it doesn't really matter where, we'll take that one there. And what we could do is bring that down to plan. So what I have done there, oh no, sorry, that's slightly incorrect. I can't bring that down. So this blue line here wouldn't give me. So again, when I look at it here, I can see, well, no, that doesn't look like it would work correctly. So what I should have done there is basically took this height here. So the blue line would be incorrect. So what we'll do is, I suppose it's important to understand what's incorrect and how we figure. So what is important to do is we'll take this, we'll call it a W here. Or a length, we'll call it length, really. Right, so what we'll do is we'll take this length, so this is 42, or we'll just take it with our compass. And that will be coming down from my parabola. Okay, so the top of my parabola would be here, and this distance here. So again, this will sort of prove the slight difference in it. What I can do now is, that would give me the width. So if I bring this up here, and bring this across to meet it, that would give me that point. Okay, so what we'll do is we'll take one more just to prove it again. So we'll take maybe a yellow this time. So we'll take one here. So again, what we'll do is we'll take the height with our compass. We mark it this way. We'll bring it across. We'll bring it up. And we'll bring this to meet it. Okay, so there's my point. So that's an alternative way of doing it. As I said, probably the least likely way that I would do it, because I understand how to use this method, but it'll depend on whether you've covered this method in class and whether you remember it. Okay.